All right, everyone. Thank you for joining. If you are watching this right now, we're very happy to have you. We have a good friend of mine, Deep, here, who is going to be presenting on a very interesting subject. And so, without any further ado, Deep, please turn on your camera and microphone, and I'll kick it over to you. I'll be here if you need me at any time during the presentation.
Sure. Thanks a lot, Daniel. I hope you can see me, everyone. Good afternoon to all of you, wherever you are, all over the world. And let me share my deck, and we can start off immediately. All right. Daniel, everything looks fine, right?
Coming in loud and clear.
Great. All right. So good afternoon again. My name is Deep. I work at Duke Energy as a data scientist. And today I'm going to talk about a Gaussian mixture model unsupervised learning method, which we are currently using to segment some energy efficiency program leads. So let's go over to the agenda. So I'll give a brief introduction about myself. Then I'm going to talk about the problem statement itself, why we are even doing this work. I'm going to talk a little bit about the data preparation and engineering. I won't go too much into the details because I want to focus more on the machine learning model itself, which is the Gaussian mixture model. And then we're going to switch over to a notebook and visualize a couple of plots. And then I'm going to give a brief recap of what we discussed. So who am I? As I told, I'm a data scientist. I work at Duke Energy. I have overall 8 years of experience in this field. I have worked across many different business verticals, marketing, sales, product distribution, etc. And also I have worked in other industries, whether it is financial services, insurance, logistics, and automotive industry. Apart from my work, I'm also involved in a couple of other stuff. I do mentor a course, AI ML course, which is initiated by Great Learning in collaboration with UT Austin University. And I have a cohort of around 20 experienced working professionals who want to upskill in the field of machine learning. Apart from that, I am involved in some local AI ML meetup groups, and I'm a Gator. I went to University of Florida. So this is who I am. And all right, so let's go to the problem statement itself. So if you guys work in the energy space, you would know that energy and utility industry is heavily regulated industry. And most of the times wherever, at least in United States, wherever you are, you have only one source, one company from where you can get electricity, power, or natural gas. So similarly, where I currently live in Charlotte, North Carolina, we have Duke Energy here. We get our electricity from here. So these are like native territories of Duke. So any customers, whether it is residential, commercial, business, any customer who get electricity or any source of energy from Duke, we call it native territories. So we know a lot about those customers. But there are many areas where Duke doesn't provide electricity because state commission rules allows only particular company to provide source of energy to particular areas. Now, there are some exceptions. Ohio, Texas are non-regulated markets where there's a free open competition where anyone can provide electricity and energy. But for us, in our current problem, we want to focus on our non-native territories. But the problem is we don't know much about our non-native customers. We really don't know who they are. And in this work, we focus more on the non-residential market because any commercial business, manufacturing, etc. entity, they use a lot of kilowatt hour of energy per hour. So we're going to focus only on the non-residential market. So let's see. So if you see, there have been in the past few years, a lot of revenue has been generated by selling energy efficiency programs by different companies in all over US. So you see, this is a report from Advanced Energy Now market report, and this is actually 3 years back. So you see it's in, the amount of revenue generated by selling this energy efficiency programs is considerably high, which is in billions. And our focus at Duke Energy is mostly on HVAC, lighting, and refrigeration appliances. So these three products, we want to sell energy efficiency programs to the customers who would be interested to become more energy efficient. So the whole business case is we have a team called BizMarket, and we have business energy advisors who go and try to find out who are these non-native property owners who would be interested in our programs. And this they do based on their experience in the field, based on their contacts, and that's how they try to gain some new customers. But what we want to do, I work in the data science solution team, and we incorporate data-driven approach to solve any business problem. And the goal is to increase the revenue considerably for this BizMarket team. And I cannot tell you the exact number, it's confidential, but it's in millions of dollars. And my goal as a data scientist is to provide them effective leads to acquire new customers. Let's go to the next slide. Now, I'm not going to talk too much about the workflow and platform. So I use Azure Databricks, and they have other components inside Azure Databricks to build the model, to deploy the model, ML flow, etc. We have close partnership with Microsoft Azure Cloud. And just to talk briefly about the data acquisition, all the data that I use, since we do not know these customers, are from third-party sources. So one of the primary source of data is called CoStar. And CoStar, if you think about it, is very similar to Zillow or Redfin or Realtor.com. If you go to Zillow website, you'll find out they list many features of a single family home or a condo, number of bedrooms, heated living areas, square feet, space, number of garages, etc., etc. Similarly, CoStar does a lot of these similar features for property owners. They have drones going all over the town, and they try to do image classification and find out what the approximate area of the property, number of parking spaces, rentable building area, how many tenants are there in a particular building, and they collect this kind of features. Apart from that, I have also used some macroeconomic indicators. So these are open source data sets. So nothing that I'm going to tell today about is like internal deep data. So we collect this data from different sources. We prepare data. I'm going to talk a little bit about data preparation, but I'm going to focus more about the model development. And that's where I am right now. This is an ongoing work. And after that, for model deployment and to have a batch scoring, we're going to use Azure as a platform. Just a little bit about data preparation and data engineering. As if you're experienced, you understand that a lot of the data we collect from third-party sources, you have to clean a lot because a lot of the data is, you have to do a lot of massaging of the data. So one of the features that I use from Azure is called Azure Maps Geospatial API to standardize many of the addresses that we get from CoStar. Apart from that, I'm just going to give just a couple of examples. I do some data imputation because there are a lot of null values, missing values. I use different algorithms and try to come up with a proxy number for those features which I think might be important for our model. All right, so Gaussian mixture model. So this is where I'm going to spend much more of the time of today's discussion. So first of all, why do we need this Gaussian mixture model? So Gaussian mixture model is an unsupervised machine learning approach. So one of the challenges is whenever we talk to this business and they have got certain leads, which is, I'm going to show you in my notebook, is 40 in number. And they know that those leads, based on their experience and work in their field for the past 3 months, they have realized that those customers have signed some kind of an agreement with Duke Energy to get energy efficiency programs. But they can't really say who are the customers who are not interested in our program. So when you build any classification supervised machine learning problem, we need to give them a true zeros, like customers who are not interested in our service and that we do not know yet. So that's why we thought better way to approach this problem would be to tackle it in an unsupervised machine learning approach. Now, one of the things people have heard about k-means clustering, which is a very popular unsupervised machine learning model to segment different different customers. But k-means is slightly different from Gaussian mixture model. So I have given two plots, the left and right, and you'd see on the left what k-means tries to do is to plot different circular boundaries across different data points, and it does a hard cluster assignment. But if your data points are not distributed properly, you would find that many of these clusters overlap. So that's why Gaussian mixture models solve this problem in the sense that instead of giving a hard cluster assignment, it gives what is the probability of a particular data point occurring in a particular cluster. So it's a probabilistic method of assigning cluster to all the data point. So let's go to the next slide. I'm going to talk a little bit about the math, not too much. Don't have time to talk everything. So the optimization method that is used in Gaussian mixture model is expectation maximization. So it has got two steps. One is the E step, where it tries to calculate certain probability density using estimated values of mean and covariance. Then it calculates posterior probability. And then there's a maximization step where it re-estimate those learning parameters based on a convergence criteria, which we give on the tolerance threshold. So just giving a few animation of how this works. I won't spend too much time on the mathematics behind it. It calculates many covariance metrics and tries to find out how many different Gaussian distributions are there in our data. And if you see towards the right, you see there are different cluster assignment. I'm not sure how clearly you can see. There's like different colors, green, pink, orange, and blue, where it, based on the number of iteration, it changes your cluster assignment and your probability value changes. So let me go to the next slide. All right, before I recap, I want to show my Jupyter notebook, and so that you guys get a better idea. So I'll stop my screen share here and I'll switch over to the notebook. Give me one moment. All right. Daniel, everything is fine, right? You can see my screen?
Yeah.
Sure. All right. So I'm gonna talk a little bit about the approach itself, so that with notebook it's easier to understand what I'm talking about. I'm gonna take only like 3-4 minutes. So idea is, so what I was trying to talk about is that we have a particular data set, and here we have different features acquired from third-party data sources. There's some star rating, which talks about the efficiency of a building. The lower it is, the less efficient the property building is, how much taxes that particular property pays. RBA means rentable building area, how much area in square feet that property has to rent out to different tenants. And then there are some macroeconomic indicators, which are household income, so per capita income, and these are on the zip code level basis. So we have this data. Now this is what I was talking about. The leads that we got from our biz market team is only 40 in number. So, and we don't know who are true zeros. That means who are not interested in our energy efficiency programs. So the whole goal is to model a population of these ones, which are 14 count, from that zero count, which is 274,000. So that is the whole idea of Gaussian mixture models. So, and I'm going to show how we can achieve this. So we do some certain steps, any machine learning steps, doing normalization of the data. So one thing we have to find out is what's the approximate number of clusters that we need to have in our data. So, and again, there are different ways to calculate this cluster, and this is still work in progress. So here, there's something called AIC and BIC criteria, where you can find out by looking at the plot what's the approximate number of clusters it may be. So in my case, I've taken a drop. The first, you can see actually another way to do it would be to calculate the gradient, but I see that there is a step here around 15 to 20, and I have chosen 15 for my today's example. And I was trying to do this many different ways. So that's how you select the number of clusters, and this is another approach. You see by 15 I see a change in gradient, so I've chosen 15 for this example. And so once I select 15 as my number of components, then I fit the Gaussian mixture library, which is from sklearn. And once I do that, you'd see what I'm interested to show you is a table and a plot. And this is what this plot is showing us, that most of our positive values of the customers that we know who have signed some kind of an agreement are in 2nd, 8th, 9th, and 12th cluster. So 30% of our positive values lies on 9th cluster, and then around 28% in the 2nd, and on around 25% on 12th. Now, what we need to do is that from this plot, we have to find out from these different clusters, which are cluster 9, 12, and 2, what are the amount of zeros? So this is like customer profiling to find out who would be interested in our programs based on the customers that we know, which are very less in count, who have signed some kind of an agreement. So another important thing, which I think might be useful for data scientists and other people, is to visualize some kind of features. So this is in a multi-dimensional space. So here it's you can correlate, though it's not exactly similar to feature importance in a classification model, but you can see how, like, for example, in cluster 2, the average RBA distance from the cluster centroid is more important for cluster 2 compared to other clusters. So whenever I switch to different clusters, so it just gives you an idea how to segment this different population of this different customers and property owners who might be interested in our program. Apart from that, the whole goal of doing this is to find probability values. Now, the Gaussian mixture model, as I told you, is a soft assignment. So instead of saying directly that this particular point belongs to a particular cluster, it gives a probability value. And business understand the classification models and their probability values that you get from the classification models, and then you can rank order the list. So similarly, we can do here. So this is one of the approach we have thought about it. So you can create the probability value, and this is what I've done without looking too much into the data. I'll give you the final results. So you see there's a probability value which comes up in many different clusters. And then so one of the solution of this problem can be choose the cluster that we are interested, profile those customers, and rank them based on their probability value, which comes up from the Gaussian mixture model. So this is one of the approach we have thought about delivering the solution to our business stakeholder. And let me go back to the deck. I will start screen share again and go back to my deck. All right, so I have only one slide to show right now. So, all right, so let me go back and do slideshow. It's not coming up from beginning. All right, but there's only one slide, shouldn't be an issue. So we already went through all the slide. So what did we discuss today? So just to get a recap of, we discussed about an unsupervised machine learning approach, which is we feel it can solve a lot of our problems where we don't have true zeros, where we don't know exactly what the customer can do. And that's the unsupervised machine learning approach called Gaussian mixture model. and all of the data that I got from third-party sources. There are some other sources where I'm still collecting data called Pitney Bowes, Dun & Bradstreet. Some of you guys might know. We talked about how Gaussian mixture is slightly different from k-means and why it is better than k-means. And also we went to a visualization where you can visualize in multi-dimensions our features and where our important clusters may lie. So yeah, so that's all I had as such in the presentation. And if I go to my next slide, so yeah, I would like to thank my team and co-workers at Duke Energy. I'd like to thank Daniel and AI4 organizers for giving me this opportunity to present at this virtual conference. And these are my contact details. My email is my first name @gmail.com. And I'm also in LinkedIn. If anyone interested to talk more about this approach or any other problem, I'd be happy to collaborate and contribute. So this is all I had. And if we have like 3-4 minutes, if someone has any questions, I'll be happy to answer them. Daniel.
Hey, thank you so much, Deep. So yeah, we have 3.5 minutes left. I thought I maybe saw 1 or 2 in the chat. If anyone else is watching and would like to ask a question, feel free. And thank you so much again, Deep.
Thank you so much. Oh, is there? Oh, let me see the chat. Okay.
And look in the chat, Deep. I think that's where you'll find it.
Oh, the first question is from Jessica. She's saying it's really interesting. Is this approach applicable to other industries projects? If so, where? So this approach is applicable in any industry. I've worked in financial services industries, in logistics industry, where we don't know who our basically, because anytime you want to target a population, because labeling is expensive and sometimes we don't know who are not interested in our product. But if you get a small population of people who are interested in our products and services, we can use this technique to segment and profile those customers, get a probability value, and later on, when we get a true label, we can build another classification machine learning model. Any synthetic data, that's true, that's right. I talked about it. I used a few imputation techniques. A lot of the data that you get from third-party sources have a lot of missing values, so we need to have good assumptions to find out how do we proxy those features. Second, from Michael, I did something similar to this in the financial industry where there are many products associated with customers. We use all internal data and no external data, lack of reliability. Okay, so the question is, we use all internal data. This project is for our non-native customers. That's what I talk about, where we do not know about those customers. So that's why we use a lot of external information. How did you find GMM? I would typically use TSNE or k-means that I've never used. Yeah, Michael, I would encourage you to use Gaussian mixture model because it gives soft assignment instead of hard assignment from k-means. Wherever the data distribution is not circular, it might give you a better result. And TSNE is it's a visualization thing. It's a little bit compute intensive. It takes a lot of memory. Actually, I was doing this in the morning. How did GMM, from Shabir Hussain, how is GMM different from random forest technique for clustering assignment? So GMM is very different from random forest. GMM gives probabilistic assignment in an unsupervised machine learning. Random forest, if you think about a classification model, you need to know what are true ones and true zeros. GMM is used where we know a little bit about a customer to extend and target other customers. From Bhanu, how efficient is Azure in standardizing the address? I've done that more than 1 million addresses. I would say it's close to 91%. From April Foreman, so in suicide, she's an interesting question. So in suicide prevention, 14 out of 20 veterans who die by suicide don't have contact with VA. I've been listening, trying to see how much metal is going to. Okay, this one I have to look at it. I won't have time to answer this. If you can email me, April, I would be happy to contribute and collaborate in your problem. Please explore Gaussian mixture model. It's a very interesting unsupervised machine learning approach. Any other questions that we have, Daniel, apart from the chat? And please encourage April to email me with her problem. I won't have time to answer this because it's already 3:15. Daniel. Maybe the presentation, the time has been over because I see that I'm in extra time. But if you can hear me, thanks a lot for your time. Please email me. I'm going to put my email again in the, yeah, April, you're exactly right. Yeah, oh, someone knows my coworker. Great. Yeah, he's a good friend of mine, Eop. And yeah, you have my email. Also, you can put my name in LinkedIn, and I should show up in the first with Duke Energy. So yeah, please email me, April, with your problem. And I'm happy to collaborate and contribute. And if you guys have any other interesting machine learning problems, I'm happy to do this. To contribute to those as well. And any other thing that you think I should do in my current work, I'd be interested to learn more that also. All right. Thank you so much, guys. Thank you so much for your time. Please enjoy the rest of the presentation. I feel there are many interesting speakers in this time's AI event. And I wish it would happen in person, but due to the current situation, it's virtual. Please enjoy the rest of the day. Thank you so much.